Hi students, in this video we are going to learn about plane. First we will see the definition of the plane. After that I will explain about plane. The definition is a plane is a flat surface. The word flat surface is very important. A plane is a flat surface such that if any 2 points A and B are taken on it, then the line segment AB join lies on the surface. So this is the meaning of the plane. Now we will explain this concept. It is very clearly said plane is a flat surface. So I will explain what happens if a plane is not a flat surface. You just look at the students. Assume that plane is not a flat surface. It is curved like this. It has a curve like this. And we are taking any 2 points on it. Let us say point A, this is point A, and this is point B. We are joining line segments with point A as a starting point and point B is an ending point. So as per the definition of the plane, all the points on this line segment AB contains infinitely many points. All those points must lie on the surface. But here if you look at it, some points of the line segment AB lies on the surface, but some points here does not lie on this surface. Hence this surface cannot be considered as a plane. Plane is a flat surface. You just assume it. I am just drawing a flat surface in which I am just taking 2 points A and B. I name it as A and B, and I am just making the line segment using the points A and B. There are infinitely many points on this line segment A and B. All those points must lie on the surface. Then only that surface can be called as a plane. So definitely a surface can be called as a plane only when it is flat. That's why they say that plane is a flat surface such that if any 2 points A and B taken on it, then the line segment AB lies on the surface. That means all the points of the line segment must lie completely on the surface. Otherwise, all the points on the line segment AB must satisfy the surface equation. I hope you understand the meaning of the plane now. Now, what we are going to do is we are going to form the equation, general equation of the plane using the definitions that we learned. So you just look at this. We shall use the definition of a plane to find its general equation. Now what we do is we are just considering the first degree, general equation of first degree in x, y, z. That is ax plus by plus cz plus d equal to 0. Here x, y, z are variables, a, b, c, d are real numbers. It is just like a general equation ax plus by plus c equal to 0, straight linear equation in 2 variables. Similarly here we are considering linear equation in 3 variables. Those variables are x, y, z. Now we are just considering this equation. We do not know whether it is a plane equation or not. We are assuming that it is an plane equation. We will check whether it satisfies. If it satisfies all the conditions provided in the plane, then this equation can be considered as the plane equation. If this equation does not satisfy all the conditions given in the definition of the plane, then this equation cannot be considered as the plane equation. Now what we need to do is we need to check whether this equation satisfies all the conditions of the plane or not. So first one is we are taking any 2 points whose coordinates, let us say first point is A, whose coordinates are x1, y1, z1. We are taking another point B whose coordinates are x2, y2, z2. So we are considering any 2 points lying on this surface. The surface is represented by this equation. When these 2 points lie on the surface means definitely these 2 points must satisfy the surface equation, this surface equation. So we are checking it. So we are substituting it x1, y1, z1 plus d equal to 0. We assumed that this is the plane surface equation, and on that surface there are 2 points. Definitely these 2 points must satisfy. So when we substitute x1 in place of x, y1 in place of y, z1 in place of z, it must satisfy. So we are keeping these two as equation 2 and equation 3, right? So as per the definition we need to take 2 points. We have taken it. After that, the line segment has to be created with the help of A and B. So we are creating, assume that we are creating it, and there are infinitely many points on the line segment AB. So all those points, infinitely many points, we know that a line segment contains infinitely many points. All those points must satisfy the line equation. So what we do is, let R be any arbitrary point on the line segment AB. We are creating a line segment with the help of A and B, and we are taking any point. There are infinitely many points on the line segment AB. We are considering any point, arbitrary point R. Assume that point R divides the line segment AB in the ratio m:n. Using the formula, section formula, we can find out the coordinates of R. After finding the coordinates of R, we will check whether it satisfies this surface equation or not. If it satisfies means, then we can say this is the surface equation of the plane, because R represents any point. That means it can represent any point on the flat surface, on the line segment. If the coordinates of the point R is satisfied by this equation means definitely the line segment completely lies on this flat surface. Hence this assumption, the equation that we assumed, can be considered as the general equation of plane. So we need to find out the coordinates of R. We will use section formula for that. So coordinates of R is, we know that m into x2 plus nx1 divided by m plus n. This is x coordinate value, and y coordinate value of R is m into y2 plus n into y1 divided by m plus n, and then z coordinate of R is m into z2 plus n into z1 divided by m plus 1. These are the coordinates of R. When these coordinates are substituted in this equation 1, it must satisfy the equation. That is, we will substitute it in the left hand side, we will simplify it, and we should get the right hand side value as 0. So since R also lies on the same plane, it must satisfy the plane equation. So in place of x, we are substituting its x coordinates, and in place of y, we are substituting y coordinate, and in place of z, we are substituting z coordinate, and this plus d as it is. Right, now we need to work on this left hand side. The value must be is 0, then left hand side will be equal to right hand side. So what we do is, since m plus n is common to all the terms, taking LCM here, d into m plus n, after that m plus n is common to all, so we are taking it out. Then what we are doing is, we are taking m as common. Here ax square, when a is multiplied inside, we are getting max square, in which we have taken m. Here also, when b is multiplied inside the bracket, we get bmy square, in which m is taken common means we get by square. Similarly here, z2, when m is taken outside, we are getting this. When a is multiplied here, we get anx1. n is taken outside as common means ax1. Similarly here, when b is multiplied with this ny, we are getting nby1. When we take n as common, we are getting by1. Similarly, we are getting all these things. Now we need to find the value of ax2 plus by2 plus cz, because a is a constant, x2 is a coordinates. Coordinate means it is a numerical value. I tell you a is a constant because in the general equation only x, y, z are variables, 3 different variables. A, B, C, D are real numbers. Hence, here A is a real number, x2, you know that it is a x coordinate value, it is again a number. So these two multiplied means it produces a number, this is again number, this is again number. When we add all together, we must get a number. We must know what is the value of this. Similarly, A is a real number, x1 is a coordinate. A coordinate means it is a numerical value. Hence, we should know these values. 1 minute students, I missed bracket here. So this is a numerical value. So we need to know what is the numerical value of this. If you look at this, ax1 plus by1 plus cz1 plus d equal to 0, right? Here also, actually here also we must have d. When we take, sorry students, here we must have plus d, here also we must have plus d. If you check it, this value is equal to 0. Hence, in this place we can put 0, m into 0 plus n into this 0. Hence, this becomes 0. So, left hand side value is equal to 0. Hence, right, it satisfies this equation. When we substitute it, its left hand side value is equal to 0 means here right side value is 0. Hence, the coordinates, the point or coordinate satisfies this general equation. Hence, this equation can be considered as the plane equation because this equation satisfies all the conditions provided in the plane definition. Hence, we can say that general equation of the plane is ax plus by plus cz plus d equal to 0. I already told you in 2D straight line equation means ax plus by plus c equal to 0. In 3D, the extension of straight line equations can be considered as the equation of plane ax plus by plus cz plus d equal to 0. When you go through this content, you will have clear idea about general equation of the plane. I hope you understand the derivation of general equation of the plane. Thank you students. Thanks for your cooperation.